You know, there is an invisible enemy living inside billions of us. It's a silent, microscopic organism that has absolutely mastered the art of survival. For a lot of people, it goes completely unnoticed, but for millions, well, it's a direct path to some serious, life-threatening diseases. So what is this hidden enemy? Let's get into it.
So I want you to just think about this question for a second, because this isn't some hypothetical what-if scenario. We're talking about a real-world threat, a bacterium that is so incredibly widespread that its connection to cancer makes it one of the biggest public health challenges we face today.
The bacterium's name is Helicobacter pylori, or H. pylori, and its reach is just staggering. It infects 50% of the entire human population. That's over 4 billion people walking around with this bug in their stomach, often for their entire lives without having a clue. This isn't some rare thing. It is everywhere.
Okay, so why is this incredibly common infection such a huge threat? Well, while most infections don't have any symptoms, when H. pylori does decide to cause problems, the consequences can be absolutely devastating. It usually starts with chronic inflammation of the stomach lining. That's called gastritis. From there, it can lead to some really painful peptic ulcers. But here's where it gets truly alarming. It's linked to cancer. H. pylori infection is a primary cause of a specific type of lymphoma, and even more importantly, gastric cancer. We're talking about the most common types that happen right in the main part of the stomach. And the scale of this problem is just mind-blowing. A stunning 90% of all non-cardiogastric cancers are caused directly by H. pylori. This is exactly why the World Health Organization doesn't pull any punches. They've officially classified it as a Class 1 carcinogen. That puts it in the very same category as things like asbestos and smoking.
Now, for decades, you'd think we had a pretty simple solution. Just hit it with a cocktail of antibiotics. But there is a huge, growing problem. This superbug is evolving way faster than our treatments, and our most reliable weapons, they're starting to fail.
And this is the first major hurdle we're facing. Our standard treatments, especially the ones that rely on the antibiotic clarithromycin, are becoming alarmingly ineffective. The bacteria are basically building up a shield against our best drugs, and that can slash the success rate of getting rid of it by up to 2/3. We are losing the fight with our old tools. But antibiotic resistance, that's only half the story.
So how does it do this? Well, H. pylori has a secret weapon, and it's called a biofilm. I want you to think of it like a microscopic fortress. The bacteria all band together and create this protective slime shield, which makes them incredibly difficult for our immune system and our antibiotics to even reach.
And this right here. This shows you just how effective that fortress is. To kill a free-floating bacterium, a standard dose of antibiotics works just fine. But once they're huddled up inside that biofilm, some studies show you might need up to 1,000 times the concentration to be effective. It's an almost impenetrable defense.
So, with resistance on the rise and these biofilm fortresses to deal with, scientists have realized we can't just keep relying on the old antibiotics. We have to get smarter. So let's dive into the new battle plan that scientists are putting together.
Okay, this diagram might look a little complex, but it gives us a fantastic overview of all the innovative strategies being developed. You can see researchers are exploring literally everything, from natural predators to super advanced nanotechnology. We're going to break down a few of the most exciting new approaches.
First up, we've got bacteriophages. These are essentially nature's own bacteria assassins. Phages are viruses that have evolved over millions of years to do one single thing: hunt and kill specific bacteria. And the best part? They completely ignore human cells, which makes them a potentially perfect, targeted weapon to use against H. pylori.
The process itself is just brutally efficient. The phage latches onto the bacteria, injects its own DNA, and basically turns the bacterium into a factory for making more phages. Eventually, the bacterial cell just bursts open, releasing a whole new army of phages to continue the hunt. It's a self-replicating, targeted strike. Now, this is really clever. Scientists are literally turning the bacteria's own weapons against it. See, H. pylori releases these tiny little bubbles called outer membrane vesicles, or OMVs. You can think of them as decoys, kind of like chaff from a fighter jet, designed to confuse our immune system. But researchers have figured out how to hijack these OMVs, re-engineering them as vaccines or as tiny Trojan horses to deliver drugs directly to the bacteria.
But the innovation doesn't stop there. We're also seeing this fascinating blend of ancient knowledge and cutting-edge science, looking at natural compounds and high-tech delivery systems.
It turns out some of the answers might have been hiding in plain sight this whole time. Scientists are now testing compounds from everyday spices like turmeric and cloves, and also extracts from plants like aloe vera. These natural agents, which have been used for centuries in traditional medicine, have shown real promise in the lab for breaking down those tough bacterial biofilms. And then, on the super high-tech end of things, we have nanotechnology. If you look at panel E on this diagram, you can see an illustration of nanoparticles. Think of these as microscopic vehicles designed to act like smart bombs. They could be engineered to get through the mucus layer of the stomach, break through that biofilm shield, and deliver a lethal dose of medication right to the bacteria's doorstep.
All of these approaches, phages, OMVs, natural products, nanoparticles, they offer incredible promise. They really represent a huge shift in how we fight superbugs. But, and there's always a but, moving from a brilliant idea in the lab to an actual treatment in the clinic is a long and very difficult road.
And that path from the lab to the pharmacy, it's filled with hurdles. I mean, first, you have to prove these new therapies are safe. Then they have to pass all these strict regulatory hurdles. And then you have to figure out how to produce them at a massive scale and at a reasonable cost. It's a really complex process that takes a lot of time, a lot of funding, and a ton of patience.
This quote from the source material really just sums up the urgency of the situation. We are literally in a race against bacterial evolution. The old way of finding antibiotics is just too slow, which is why this explosion of creative, alternative research isn't just important, it's absolutely essential.
Which really leaves us with the ultimate question. H. pylori is a formidable enemy. It's coexisted with humans for millennia. As it continues to adapt and resist, our own creativity and scientific ingenuity are our best weapons. The battle is far from over.